Welcome to all. In this video, we will continue with the scheduling algorithms. So in the previous video, I talked about CPU scheduling, but with respect to scheduling algorithms, there are some algorithms which you have to understand and you have some problems to solve as well. Okay, the CPU scheduling deals with the problem of deciding which of the process in the ready queue is to be allocated to CPU. That is nothing but whenever you are considering the ready queue or the in queue in which the process are ready for the execution. So these algorithms will decide that which process has to be given to the CPU. So for the execution of that particular process. So again, it depends on the algorithm, because some algorithms deal with the priority of the process. In some cases, they deal with the fashion in which the process has come to that ready queue. So there are so many variations we can see with respect to the algorithms. So we will see one by one. So in this section, we describe several many CPU scheduling algorithms. So there are some of the algorithms which I have already listed. So the algorithms which are in bold, okay, in bold format, they are available in your syllabus. Okay, rest of the things are just for your knowledge. Okay, the first one is first come first serve scheduling. The second one is shortest job first, or SJF scheduling. Next, priority scheduling. Then there is a concept of shortest remaining time scheduling, and one more is round robin or RR scheduling, and multiple level queues scheduling. So these are the main scheduling algorithms which are available for the this process. So depending on the architecture and depending on the developer who has developed the process management and handling of this scheduling algorithm, they might have gone for some kind of algorithms. Okay. So the first one is first come first served scheduling. By far the simplest CPU scheduling algorithm is the FCFS. Okay, that is nothing but first come first serve. With this scheme, the process that requests the CPU first is allocated the CPU first. That means whenever it is something like stack operation, isn't it? So first come, not stack, queue operation. First come first serve, or first come first out, isn't it? In case of stack, what you're doing, first come last out, isn't it? You can think of DS or data structure concept. So you can consider the stack and queue operations. Okay, so in this case, it is something like if you are coming for the first time, you are served first. So it is something like in the standing in a bank queue or post office queue. So if you are the first person to stand over there, you will be served first. In the same fashion, this particular scheduling algorithm works. Okay, when a process enters the ready queue, its PCB is linked on to the tail of the queue. Okay, so this is nothing but the control block. Okay, process control block. Okay, when the CPU is free, it is allocated to the process that at the head of the queue. The running process is then removed from the queue. So once it is being served, then it can be terminated. Fine. So this is the rough idea of this particular FCFS scheduling. Okay. So it is an operating system scheduling algorithm that automatically executes queued request and process in order of their arrival. So that is what I just explained. So they are going with respect to some standard sentences. Okay, it is the easiest and simplest CPU or scheduling algorithm. In this type of algorithm, process which requests the CPU first gets the CPU allocation first. This is managed with the FIFO queue, the first in first out queue. The full form of FCFS is first come first serve. So these are the theoretical concepts which you have to understand with respect to the exam point of view, because anyway we are going to solve some problems on this FCFS. So definitely in the next video I will manually solve and I will upload that video so that you can visualize what happens when you have so many processes in a queue and how exactly this performance can be monitored. So we will have some terminologies in the next slides. We are going to see those as well. Okay, as a process enters the ready queue, its PCB, process control block, is linked with the tail of the queue, and when the CPU becomes free, it should be assigned to the process at the beginning of the queue. So these are the theoretical concepts which you have to understand. Once you manually solve the problem, you get to know, and you will definitely get the idea of this particular scheduling algorithm. Okay, there are some characteristics which you have to understand. So it supports non-preemptive and preemptive scheduling algorithm. So what is the difference non-preemptive and preemptive? So it is something like, so if one process is given to the execution, it will never allow some other process to work on it. Okay, so that is the thing. Okay, and the next in some other case, so based on the priority, it can be exited from the execution, or it can be put to the waiting queue until and unless that most priority thing is being executed. So but in this case, in the case of FCFS, it supports both non-preemptive and preemptive. Okay, the second point is jobs are always executed on the first come first serve basis. Okay, so it is easy to implement and use. So there are in C program, there are some programs itself for the FCFS. It's for this algorithm, entire program is available. So I don't know whether you have lab or not for this OS. I will check with the syllabus, but if you don't have the lab, definitely you can get the entire code in the internet. If you are not getting, you can contact me. I will get you the complete C code for FCFS. So that is just for your knowledge, just to know that how exactly it is working with respect to programming level. How can you implement FCFS? That is the reason. Okay, the next thing is this method is poor in performance and the general wait time is quite high, because until and unless you are not going for the next process, isn't it? So once if the first process come to that execution, until and unless it completes, it won't allow to it won't allow the other process to enter. Some kind of points will be there, or some kind of idea, or scenarios will be there with respect to FCFS. Okay, there are some disadvantages which you have to understand. This scheduling method is non-preemptive. That is, the process will run until it finishes. So that means it won't allow other process to get into the execution. It is something like, say for example, if I want to give the real-time example, so say for example, you are standing in a line in a bank system. Okay, inside the bank. So for example, there is one old man comes and he is not feeling well, and he asks you to allow him to go in the next step, like for his process or for his work, maybe for withdrawal of the money or any depositing money, it depends. So if you are a good person, definitely you will allow, isn't it? Based on his age and his health condition, he should be allowed first. As a human, I'm just considering the being human tag. Okay, it's a kind of humanity. Fine, but with respect to some confused people or greedy people, they will never allow them. They want their own work to be done at first. They will never understand others situations, or they will never understand others problems. Okay, in the same fashion, so non-preemptive is nothing but it will never allow other process, whatever it may be the priority, whatever it may be the urgency, it will never allow the other process to execute. It will execute its process first and it will terminate, and then whoever it may be, they can access the process, this CPU. It will never bother. So this kind of algorithm is called non-preemptive. Okay, because of this non-preemptive scheduling, short process which are at the back of the queue have to wait for the long process to process at the front to finish. So this is again one more example I can give. So for example, there is one woman standing in front of you in a bank system, for example. So she wants to open a FD. Okay, she wants to deposit some amount for the FD. So there is a long procedure, isn't it? You have to fill up some forms, and you have to stick your photo, and you need signature, you need nominee, you need witness, and so many criteria are there which has to be filled. So it takes, say for example, say 15 minutes. So she is not allowing anyone else to move with the queue. She is standing over there and she is filling up all the things. But you went just to update your passbook for the balance. Your work is very short. You are just giving your book to that person who is sitting in front of that desk, and he or she will take your book, and it will be printed and it will be given to you. It is just hardly 5 minutes work. But because of that person who is standing in front of you, because of her or him, so you have to wait for 15 minutes along with your 5 minutes. So it will be total 20 minutes you have to wait in the bank just for your passbook get updated. Did you understand? The same concept for process also. If there any short-term processes are waiting in the queue, it has to be wait for the longer duration for the execution with respect to FCFS. Okay, so that is the thing they have updated over there. Next, there are terminologies which you have to understand. First one is arrival time. So the time at which the particular process has arrived. So again, it depends on the arrival time. The best example for the scenario, these scheduling algorithm scenarios, best example is you are getting into the bank, and a crowded bank. Say for example, you are going on Monday for crowded bank, or you are going to the bank when the year end comes, for say for example March end or something like that. Fine. So at that time the bank will be fully crowded, and that time you can make an idea, or you can get the rough idea that how exactly these terminologies matters. Okay, arrival time is nothing but the process which has arrived. Completion time is nothing but time at which the process completes its execution. Okay, to overall execution. It may be any work of that particular process. Overall execution is calculated using the completion time. Next, turnaround time. The time difference between completion time and arrival time. That is nothing but that gap. At what time you have arrived to the bank, and at what time you are complete execution. It may be for bank updation, or this one passbook updation, or it may be for creating some accounts, or withdrawal or deposit, or it may be anything. Your complete process. So once you finish with your process, you are coming out of the bank, isn't it? So total duration, it is being calculated over there. So there is a formula: turnaround time equal to completion time minus arrival time. So you have to remember this particular formula. So why I will say, so the question will be like, they will give some process and their arrival time as well. So your work is to calculate the turnaround time as well as average waiting time. So how long that particular process waits. There are some, the methodologies to calculate all these things. When you solve the problem, you get to know. But as of now, you just remember the terminologies. Fine. The next thing is waiting time, WT. The time difference between turnaround time and burst time. So there is a concept of burst time. So I will say what is a burst time when we deal with the problem. Okay. So that is nothing but the turnaround time minus burst time. So you have to remember this formula as well. Fine. The next thing is you have to see the main difference. So it is for your knowledge, for your knowledge purpose, as well as it can be a particular question which can be asked. Fine. There are some I have listed some 4 to 5 differences. So you can see primitive scheduling and non-primitive scheduling. The first, for primitive scheduling, the CPU is allocated to the process for a certain amount of time. Okay, in case of primitive scheduling means, if for example the process is getting executed, at that time if any other higher priority process come into picture or come into the queue, then definitely it has to go to some other place, and it has to wait for the other process to execute it. So okay, so that is the actual idea for preemptive. For in case of non-preemptive, it will never allow other process to execute. Okay, so in case of non-preemptive scheduling, the CPU is allocated to the process till it ends its execution or switches to waiting state. That is a voluntary one. You cannot do that. If the process wants, it can switch. Otherwise, it will never allow. Fine. The next point is for preemptive, the executing process here is interrupted in the middle of the execution. That is the reason why I said if higher priority or any other scenarios occurs in the process execution, it has to be terminated, or it has to be paused. I am not saying that terminated. I should not be using that word termination. It can be paused or it can be interrupted. That will be the better word I can use for the sentence. Fine. The next point for non-preemptive is the executing process here is not interrupted in the middle of the execution. So that means until unless it finishes the execution, it will never allow. That is the meaning. The third point is it is usually switches the process from ready state to running state and vice versa, and maintains the ready queue. That means based on the requirements, based on the scenarios, under the non-preemptive scheduling algorithms, there are so many preemptive scheduling algorithm as well, and there are some non-preemptive scheduling algorithm as well. But in case of FCFS, it supports both, but it majorly concentrate on non-preemptive scheduling technique. Fine. So in case of primitive scheduling, it does not switch the process from running state to ready state. So it will be keep on executing. So the next point is here, if a process with the high priority frequently arise in the ready queue, then the process with the low priority has to wait for the long, and it may have to starve. That means, say for example, you are taking your vehicle on the road. Okay, so in some certain point of time, or in a particular point of time, a VVIP vehicle is getting passed by your vehicle. If that is the case, definitely this signals, definitely this traffic police people will stop you all. Once that VVIP vehicle has just passed, then you are allowed to move further. In the same fashion, if there any higher priority coming to picture, the low priority process has to wait. And wait is nothing but starvation, isn't it? It has to be for the execution, for the resource allocation, it has to wait for the longer duration. That is the meaning. In case of non-preemptive, here if CPU is allocated to a particular process with the larger burst time, then the process with the small burst time may have to starve. So I will say what is a burst time, because each and every process will be given with its own time slot. Okay, based on that time slot only, you are going to calculate for the problems. Okay, so when we manually solve the problems, you will get the best idea or clear picture of this table, and this arrival time, completion time, or turnaround time, waiting time, or average waiting time, or burst time. So all these terminologies you are manually going to solve. No need to worry, it's very simple. FCFS is very simple. So in the next, definitely in the next video, I will manually solve, and I will show you how exactly this particular algorithm is working. Fine. In case of preemptive, the last but not the least point is, it is quite flexible based on the switching between the execution state and ready state, or waiting state. It is a flexible one based on your scenarios, or based on the CPU scenarios. The process may be getting flexible. Okay, but in case of non-preemptive one, it is rigid, as even if a critical process enters to the ready queue, the process running CPU is not disturbed. It will never ever allow any other process to run on its platform. That is the meaning. So these are the some of the major differences between preemptive and non-preemptive CPU scheduling algorithms. So you have to understand these concepts, but no need to worry. Don't worry much about these terminologies. Once you solve it, you are going to get the best idea of this particular scheduling algorithm. No need to worry. Fine. So let me wind up the video as of now. So in the very next video, I will solve the particular problem. So that time you are going to get the better idea of FCFS scheduling algorithm. Okay. Thanks for watching.